Welcome to section 5.1. Most of this section is review from Algebra 1. We are going to be working on exponent rules, and so I'm going to go through a couple of the rules. At some points in time, you will want to pause this video, maybe it's now, so that you could actually write in the examples. I know they're not, or if they're listed on your paper, I think they're handwritten, but I wanted to put those in. And we're going to talk about properties for one, and then we'll do a couple examples to go along with it. Okay, so let's start with the first one. The product of powers property says that if I have a base raised to an exponent of n, and I multiply by the same base raised to a different exponent, that's key, a different exponent, what I'm going to do then is I'm going to keep the base the same, and I'm going to add the exponents. Okay, keep the base the same, and add the exponents. And so maybe you want to put a little note, add exponents, something like that. So here's what we're going to do. All of these bases in example 1 are the same, so I'm going to leave base b. And then what I'm going to do is take -4 plus 7 plus 6. Well, -4 and 7 is 3. 3 plus 6 makes 9, so my answer is b to the 9th. Okay? Same thing with an example 2, but I like to do a negative with you. I'm going to look at the first -5, and there's not an exponent there, so now I know the exponent is 1. So I know my base stays the -5, and I take the exponent of 1 and add it to the cube, the 3 that's there, and I get -5 to the 4th. Okay? Similar type of idea, we're going to use scientific notation, and we're going to do some of this. This is a chemistry and science type application. What we're going to do is we're going to take the like terms and we're going to multiply them. So 4.5 times 3.7 is 16.65. Okay, times, now you'll notice these bases are the same, so we're going to have it times 10, and I'm going to add the exponents. So 3 plus -1 equals 2, so it's 10 squared. The one thing I want to talk about, though, is the rules with scientific notation. And you'll notice my original scientific notation was one number, then a decimal. So I need the same thing to happen. So I need to move this decimal place over 1 so that I end with 1.665 times 10. And we're going to look at how to move this. Originally, it was right here between the 6, and if I move it twice, I get rid of the decimal place. Well, here, now I have to move it 1, 2, 3, so I'm going to raise it to the 3rd power. So if I move it twice, it's the 2nd power. If I move it 1, 2, 3 times, it's the 3rd power. Okay, and we will work a bit on scientific notation, but I know most of you have had chemistry before, so this is probably not new. The second one is called power rules, and powers mean we're dealing with multiplication of exponents. And so here's how the rule goes. If I have a base to an exponent of m, and I raise that again to a new power n, what I'm going to do, let's start with the right letter, I'm going to keep the base like we did before, and I'm going to multiply my exponents, okay? So maybe you want to write a little note again, multiplication of exponents. There's a second one that says if I have 2 different bases inside of parentheses and I raise it to an exponent, the exponent gets distributed. Now only when it's multiplication inside. So a to the m times b to the m. Last one for this column, if I divide, a quotient means division, and I raise it to an exponent, then like with the multiplication, I'm going to distribute, so a to the m divided by b to the m. Okay, we're going to practice a couple. Now, as I look at this, there are multiplication 4 times m squared times n cubed. And I'm going to put in those multiplications because every time I see a multiplication, basically every number I have in between, I'm going to raise to the power. So I take 4 to the 4th, and I get 256. M squared to the 4th means I multiply my exponents, I get m to the 8th. N cubed to the 4th means I multiply the exponents, I get n to the 12th. There's there's my answer. Okay, so there are three different things, 4, m, and n, so I take the fourth power to each of those. And you can think about it in terms of a distribution. Now, the next one we're going to do is we're going to look at this, and I'm going to run maybe out of room. I might write a little bit out elsewhere, but here's the idea. This 3, there's 3 things on top and 3 things on bottom. So that 3 is going to go to each of them. So 2 cubed is 8. X cubed means I multiply the exponents. I get an x to the 9th. And then the y to the first means I multiply, I get a y cubed. All over. 4 cubed is 64. Y squared cubed means y to the 6th. And finally, z cubed is just a z cubed. Okay? Now our goal here, and I'm going to swap colors a minute so we can kind of see this. Our goal here is to simplify. So I divide, the division bar means I divide. I divide 8 by 64, and I get 1/8, which means 8's going to go on the bottom. You can put the 1 on the top, I'm just going to wait. Okay? X to the 9th, there's no other x's on the bottom, so I'm going to leave it as x to the 9th. Y cubed and y to the 6th. What I'm going to do is there are 3 on top, which will cancel with 3 of them on the bottom. So if I take away 3 from y to the 6th, I still get y cubed, and that's on the bottom. And the last one, z cubed, there's no other z's, so I leave it there, and there's my answer. Okay, and we'll talk about that canceling too as we go on, but I wanted to give you a general idea. The next property is called a quotient. What that basically says is if I have one base to an exponent and I divide it by the same base to a different exponent. Okay, what ends up happening, if you look at the multiplication, when we multiplied same bases, we added the exponents. When we divide same bases, we keep the base and we subtract the exponents. So here's how it works. If I have 11 to the 8th and 11 to the 5th on bottom, I keep my 11 and I subtract 8 minus 5 to get 11 cubed. Now I'm going to leave my answer here. I know you can actually go and find 11 cubed in your calculator. Right now I just want to work on exponent rules. Okay? We're going to take example 2 like we did below, and I'm going to divide the numbers. 16 divided by 2 is 8, and I'm going to kind of write it on the top. Second thing, m to the 4th. There are no other m's, so m to the 4th stays on top. And n's, what I'm going to do here, because one's on top and one's on bottom, I'm going to subtract them. So negative 5 minus negative 7 means I add. Negative 5 plus 7 is 2. I have n squared. There's my final answer. Okay. Last but not least, like we did scientific notation, we're going to divide the numbers. You end up getting 0.383. We're going to have times 10 because the bases are the same. If I subtract negative 3 minus negative 5, that means I add it. You get a value of 2, so times 10 squared. Now again, the problem here is that if I do this, I need my decimal place to be 3.83. Okay? So, what I want to do is basically, I had to move it 1 to the right. So that's times 10 to the 1st. And I will explain that one a little bit more in class as to why it now got smaller this time instead of bigger. We'll look at that. I just want to kind of give you the idea of what's going on here. Okay? Negative exponents, if I have a base to a negative exponent, negative exponents make a note, take reciprocals. Okay? What that means is I do 1 over a to a positive exponent. And last but not least, the last power is any base to the 0 power is always 1 no matter what. And so we're gonna work with both of these. Here's what happens. If I look, I have this whole thing to the 0 power. I don't care what happens inside, it doesn't matter. Because anything to the 0 power is always 1 no matter what's inside. Last but not least, we're going to distribute this -2 to each of these. So I have c to the -2 power, and I multiply these exponents, and I say d to the 8th power. Now, negative exponents, we said above, make reciprocals. So this 2 is on top, which means I'm going to move it on bottom and make the squared negative. So what's left on top is nothing. I need a placeholder. 1 over this 2, the c comes down, so now it's c squared and d to the 8th. Okay, and there was nothing on top. Wherever's negative, if it's on top, it moves to the bottom. If I find a negative on the bottom, I can move it to the top. Okay, so this is kind of the idea going through. This is just a general review. We're going to practice more with exponents in class, and I'm going to give you a warm-up, and we're probably going to use whiteboards to just practice that exponent rules go well. But I just wanted a general overview as to what exponent rules look like again. Okay, so thanks for watching 5-1.